This is the law of sines, a very useful formula that we can use to find unknown triangle sides or angles. But how do we know that it works? And how do we prove it? To begin, let's start with a triangle and let's try to find its area. We know that the area of a triangle is 1/2 base times height. Based on our triangle's current orientation, our base is the length c. But what's the height? The triangle is not a right triangle, so neither A nor B represent the height of the triangle. The height can be visualized as this line running down the middle of the triangle. And with this line, we can now divide our current triangle into a smaller triangle. This triangle is a right triangle, and it has the same height of h. We know an angle in this triangle, A. The sine of angle A is the opposite, in this triangle that's the height, over the hypotenuse, or length b. To isolate the height, we can multiply both sides by length b, and we find that the height of this triangle is b times sine of angle A. We just found one of the areas for this triangle. Now, you may have noticed that when we split the triangle in half, we chose to use the triangle on the left. But there's also a triangle on the right, which we could also use to find the height. This time, we take the sine of angle B. This is the opposite, which is still the height, over the hypotenuse, or length A. Now, if we solve for h, we get A times sine of angle B. The base of the triangle is still the same, length C. We just found another way to represent the triangle's height, so we just found another formula for the area of our triangle. Now, this too is a valid formula, even though it doesn't look exactly the same as the one we found earlier. Since we know that these are the same, we can simplify an equation. After some quick simplification, we have the first chunk of the law of sines. Time to solve the last part. We will start with the same triangle as before, but this time we'll rotate it. This will give us a new height and a new base, length b. Now, like before, we could find the height using either the triangle on the left or the one on the right. Both would help you solve for h, but let's choose the one on the left because it has angle c. In this right triangle, the sine of c is the opposite, the height, over the hypotenuse, or length a. This means that h is A times sine of angle c. That's the height. So now we have another expression for the area of this triangle. This area is equal to the ones we found before, since all of these represent the area of the same triangle. Remember, to find the third expression, we didn't change the triangle, we just rotated it. So now if we pick one of our previous expressions and compare it with our current expression, we can do some more simplifying. And with that, we found that c over sine of angle c equals b over sine of angle b, which we know equals a over sine of a. And that is the law of sines. If you found this helpful, be sure to like and subscribe and check out some more of my videos. Thank you for watching.